things you saw in the homework or things we've been talking about or in general. So we'll just kind of start with any kind of clarifications or homework questions or anything that kind of might be on your mind there. Did you check in the office for coming in late?
Yeah.
You did?
Yeah.
Okay. They usually give you a yellow pass. Okay.
No, I don't do that anymore.
Oh, sure. Sure. Okay. That's fine. I'm just double checking, that's all. All right. So, does anybody have anything they want to talk about or ask about before we get going? Yes. I just moved my picture of where everybody's at because the old one I had wasn't any good anymore. Megan. Yes. Mm-hmm. Sure. Yeah. So if we're looking at homework 1, or homework, did you say? It doesn't matter. It's the same number 6, right? It's the same picture. Okay. So you're asking about the range for this, right? Yeah. So you're going to have to estimate a little bit off of the graph, which is fine. As long as your estimate is pretty reasonable on a homework assignment, like that's not a big deal. Like if somebody says it's 1.5 and you say 1.3, like I'm not going to complain about something like that on a homework assignment. So if we're talking about the range specifically, we care about the y coordinates. So I'm going to first hunt down the lowest point on my graph, which to me looks like it's kind of right there. You agree with that? So if I read that point off, that looks to me like 0, -1. Okay with that, Megan? So that would be the first point in my interval, or the first number in my interval. And I'd look for a highest point. Well, it seems like the graph is continuing on kind of forever here. Hi, Arlie. Megan, it's for you, coincidentally. It's going on forever there. So because it's going on forever to the right, I would think about it as like that, the point positive infinity comma positive infinity, because it's going to the right, so the x values are getting bigger, and it's going up, so the y values are getting bigger. But since it's a range, the y values are what we care about. We know the parenthesis, or the infinities always get a parenthesis. And then for the -1, I have a point that actually has that, so that one gets the bracket.
So could you decide if you wanted to do like negative or positive infinity, because like it's both going infinity on like both sides? Does that make sense?
Well, you think about like what the highest point is.
Oh,
if you think about this highest point, sure, that's negative infinity, but the y, it's pointing up, so the y coordinate is still positive infinity.
Okay.
So when we talk about the range, the y coordinate is still positive infinity on either side.
Okay.
Does that feel okay?
Yeah.
So don't get confused on the x and y coordinate,
Okay.
which is what it kind of sounded like we were getting jumbled in there.
Okay.
Does that feel good?
Yes.
Okay.
Thank you.
You're welcome.
So if you do like the domain, do you think it's negative or positive?
So the domain, we're going to look for the, start by looking at the point furthest to the left, which would be this one, right? And here we care about the x coordinate. And then we're going to look for the point furthest to the right, which would be this one. And again, it's a domain, so we care about the x coordinate. And then since they're both infinities, they both get a parenthesis. Does that feel okay? So again, you're looking at, for the domains, you're looking at furthest left point to furthest right point. For the range, you're looking for lowest point to highest point. And sometimes those could be the same, right? The farthest left point could also be the highest point or the lowest point, right? That can happen, and that's okay. But that's kind of the easiest way to think about it. Elizabeth, you're happy with that?
Yes.
Okay. Paradise. 10? Sure. So, 10, are we just worried about the domain and range part?
Yeah.
Okay. So we'll start with the domain. So we're going to start by looking for the furthest left point, which is this one. And then the furthest right point, which is this one. But we also have to be kind of concerned with the fact that the graph isn't connected, right? There's a piece that's separate. What I don't have to worry about I don't have to worry about this with the domain, because every point on that circle, its x-coordinate is also used on like this part of the V, right? So since all of the x-coordinates on the circle are also used on the V, I can just ignore the circle when it comes to the domain. Does that feel okay? Okay. So the domain here would just be negative infinity to positive infinity. For the range, we're going to find the lowest point, which would be here, at that looks like -3, -1 if I was going to make an estimate. And then the highest point would be either location, it doesn't really matter. But here we have to be a little bit careful because the 2 points that we're considering are not connected together. However, if I look at, say, like this section of the V is got all the y coordinates for that part of the circle, right? And then all the parts below that, and then obviously the circle is all connected together. So all those y coordinates are kind of overlapping. Does that feel okay there? It's a little subtle to see that, and it's not easy. This is, I think, the trickiest one on the sheet. So we can just treat this as one interval. It's fine, because all the y coordinates are kind of overlapping. The y coordinates from the V overlap with the y coordinates of the circle. So in a way, the y coordinates are all kind of connected. Do we see that? Okay. So I can just start with my lowest y coordinate, which is the -1, to the highest y coordinate, which is either side you pick is positive infinity. And because there is a point that has that y coordinate of -1, that's going to get the bracket, and the infinities always get a parenthesis. Cool? Okay. And these are good questions that you're asking. I'm happy to go through like old homeworks like this, even though we've already submitted these, or if it's a homework along the way that we want to ask questions about, like, you know, if you're catching in between the due date and the assigned date, happy to do that sort of thing. This is, I think, really productive time that we're spending kind of talking through how to do these things, especially after you've spent a little bit of time thinking about it and you're still not sure, right? It's nice to kind of get some, you know, closure on whether these things are, you know, you're thinking about it correctly or not. Or like, ooh, this is a weird kind of situation that I'm not really sure how to think about it. Clarification there can be really helpful. So this is good time that we're spending here doing this, and I'm happy to do this. And typically, it's, you know, now that we've had some homework assignments, this is how I'd like to start kind of every day of class, is taking some questions from the homework and reviewing some of these ideas and, you know, reinforcing things before we get going. Okay? Last call on this stuff, on the questions before we get moving forward. Number 5?
Yeah.
Okay. So you should recognize this as in the form of y equals mx plus b. Okay with that, Elizabeth?
Yeah.
Okay. And y equals mx plus b is just the equation for a line, right? In particular, we can say well, this line's going to have a slope of 3 and a y-intercept of 1. So it's going to look something like this. Is that okay? Now that I have a picture of it, I'm going to approach this just like I did 5 or 10 to figure out the domain and range. So this is my furthest left point, and this is my furthest right point. So my domain is just going to be negative infinity to positive infinity using the x's. Oops, I'm so silly. That y-coordinate should be negative, right? That arrow's pointing down. And the range, similarly, this is my lowest point, this is my highest point. So again, it's negative infinity to positive infinity. So the idea, if you have an equation, is just try to translate it into a graph so that you're able to deal with it. That's usually the easiest way to go about doing it. Now, in the beginning of the semester here, that's rather challenging because there's lots of functions that we're not really familiar with, and we don't really know what the graph is going to look like in general. One of the things that we'll accomplish as we move through this semester is we're going to study some different types of functions. And the hope is that when we give you the general form, you'll then add that to your toolbox. So when you look at an equation, you'll go, oh, this looks like this kind of function. So I know the graph is going to look kind of like this. And you'll be able to just immediately have some information at your fingertips about what it is you're dealing with and kind of what to expect. Now, we don't have that yet. So like when he's giving you an equation, I'm rather limited on things that you should be familiar with, like the equation of a line, like y equals mx plus b. Which I think when we did the review of algebra ideas, this was something everybody remembered seeing. So I felt like that was going to be safe to put in there. But on a test or quiz, I probably would not give you the equation without a graph. Unless it was something like a line where I'm certain that we've all seen that form before. Okay? Okay. So let's move forward then. So from last time, we'd been talking about like attributes of functions. And one of the attributes we talked about was positive, negative, and 0, where we said positive was the parts of the graph that are above the x-axis. Negative were the parts that were below the x-axis. And 0 were the parts that were on the x-axis. Right? We did this last time or no? Yes? Okay. So let's just do a little quick, yes, Megan? Attributes of functions? Yeah, you're welcome. So we'll do a little example here to just kind of refresh how to do this kind of thing. And then we'll go and start talking about the next couple of attributes. So we'll just start with a little refresher from last time. These are all things that we did last time, and I think you had a couple problems in your homework doing this. I think the next homework assignments, I'm also going to ask you to do this skill again, so I figure it's a good time to do some refresher. Okay? So here's an example, and I've gone ahead and written in the ordered pairs for the points that are going to be of interest to us. And this is probably as hard as I would give you guys, as hard as an example as I would give you on like a test or a quiz, or maybe this is even harder than something I'd reasonably give you on a test or a quiz or whatever. So let's start with the positive parts. So how many positive parts do you see for this graph? 2. That's good. We should see 1 here and 1 over there. Everybody okay with that idea? Okay. So let's look at the first section of that positive. We're going to find the leftmost point on that section, which is this one here at negative infinity, comma, positive infinity, right? Everybody's okay with that? When we write these intervals, all we care about are the x-coordinates. So this positive section starts at the x-coordinate negative infinity, and it ends at this point here, negative 6, 0. So the x-coordinate it ends at is negative 6. Is everybody okay with that? Now remember, when we write our intervals, we always use a parenthesis when we have an infinity. That rule still applies here. And now let's decide whether we should use a parenthesis or bracket on the negative 6. So we have to ask ourselves, where is the point negative 6, 0 located? Is that located above the x-axis, which would be the positive stuff? Is it above? No. So should it be included with the positives? No. Okay? So we'll do that. And then we'll worry about the second section of our graph. Remember, the symbol that we use to connect two intervals is that union symbol, that U without a tail on it. And we'll do the same thing for that second section. So the leftmost point there is this point 5, 0, but all we care about is the x-coordinate. And its rightmost point is this one, positive infinity, comma, positive infinity. So again, all we care about, though, is the x-coordinate. And we know the infinities always get a parenthesis. And then we need to ask whether that 5 should get a parenthesis or bracket. So again, I ask myself, where's the point 5, 0 located? Is it above the x-axis? No. So it gets a parenthesis. Yes, sir? No, that matters. So again, you need to be thinking about, this would translate to the inequality, like 5 is less than x, which is less than positive infinity. If you reverse that, that's saying that x is greater than positive infinity, but it's less than 5, and that's nothing. That's no set of numbers. So you really, the order in which you write your interval matters. It needs to be from the smaller number to the bigger number always. Now, you could have reversed these two intervals where the union is between them, and that's okay. But you can't reverse the numbers in the pairs. Walter, are you good with that?
Yeah.
Okay. So that's an important question. I'm glad somebody asked about it, because that's something that is a frequent mistake I see from students. While I wouldn't mark off all points for that, I would, there would be some kind of deduction for having those in the wrong order. Is that okay with everybody? Okay. All right, so let's do the negative part now. How many negative sections do we see here? I also see 2. There's this section here, and then this section here. Everybody's okay with that? Okay. If I look at that first negative section, the leftmost point is here at -6, 0. But all we care about is the x-coordinate, so we'll write the -6. And its rightmost point is here at -3, 0, but all we care about is the x-coordinate, so we'll write a -3. Now we'll ask ourselves, okay, that point -6, 0, is that below the x-axis? No. So it gets a parenthesis. -3, 0, is that below the x-axis? No. So that'll get a parenthesis. Why did my question change from above to below? Because we're talking about the negative stuff, right? And that was the definition of our negatives. Very good. So then we'll use our union symbol to connect the next interval. That next interval starts at 2, 0, but all I care about is the x-coordinate. And it ends at 5, 0. But again, all I care about is the x-coordinate. And then I'll look at the location of the point 2, 0. That's not below the x-axis, so that gets a parenthesis. And 5, 0, also not below the x-axis, so that gets a parenthesis. And our last one, is the 0. How many 0 parts do we see for this graph? What do you guys think? How many 0 parts do you see? I see 3. So there's this spot in the middle that probably everybody notices. That's certainly one of them. But there's also this single point here and this single point here. So the graph actually is on the x-axis in 3 different spots. Does everybody see that? Okay. So let's take a moment here and point out that those 3 different spots, only one of them are we going to describe with an interval, because only one of those spots contains an infinite number of points. That's that section in the middle that's a connected line. The other 2 spots are singleton points, which we cannot write as an interval. We're going to just use like that curly set notation to describe those ones. Is everybody okay with that? Okay. So let's do the interval part first. So if I look at that section in the middle, it starts at -3 and it ends at -2, or +2, excuse me. Is everybody okay with that? Now I'm going to ask myself to determine whether I use a bracket or parenthesis. Is -3, 0 on the x-axis? Yes, right? So that gets a bracket. And 2, 0, is that on the x-axis? Yes. That gets a bracket. So then I'll use my union symbol. And as I mentioned before, now I'm going to use a different set notation because the other 2 places where the graph is 0 are just single points, right? So the x-coordinate at that first single point is -6, and the x-coordinate at the other single point is +5, and I'm done. And I would say that this is as hard or harder than any expectation I would have of you guys on a test or something. So if you felt like that was pretty easy, then you're in good shape. If you're like, that was kind of hard, well, it won't get harder than that. Yes, sir.
Does it matter, like, where you put, you can do the back.
Okay, so the order of the pieces that have the unions in between them does not matter. The order of something in a curly set bracket doesn't matter. The order of the numbers inside an interval, that does matter. Has to go from small to big. These are all great clarification questions. I'm happy you're asking because those are natural things that you should be thinking about to kind of cement what we're doing here, right? Because we're seeing the notation is important and asking, like, is this still the same thing, right? Sometimes order has mattered and sometimes it hasn't. So those are important questions to be asking. Is everybody good on the what matters and what doesn't in terms of the orders here? Okay. We feel okay about positive, negative, and 0? Okay. The next attribute that we're going to talk about is increasing, decreasing, and constant. And just like we did for positive, negative, and 0, I'm going to define these really informally. So when I say increasing, we're really talking about a part of the graph where we're walking uphill. Now, when we say walking, we're talking about going from the left side of the graph to the right side of the graph and like walking along the curve. Is everybody okay with that? Imagining that in your mind's eye? That tends to be the easiest description for students. So decreasing is downhill, and constant is flat. And I put the little quotes around these things because we're not really defining what uphill, downhill, and flat means, but it's kind of one of those things like you know when you see it, but to actually define it rigorously is a little bit more challenging, and I'm not really interested in like a rigorous definition because we're not going to prove anything with this. We just need to be able to know it when we see it. And I think this is good enough for that. Is everybody happy so far? So let's look at an example. So I'll draw a little graph here. Okay. So if we look at this graph, how many sections do we see that are increasing? So if it helps you, you can think of like a little person kind of on top of your graph and walking along, and when that person is going to be going uphill or downhill. So I see two sections where the graph is increasing. So obviously here at the start, right, we walk uphill until we get to the very top. And then we have another increasing section over here at the end where we start walking uphill and we go forever. Everybody's okay with that? So the first increasing section begins here at the left arrow, which because it's the left arrow, it's negative infinity as the x. And because it's pointing down, it's negative infinity for the y. Is everybody okay with that idea? And we walk uphill until we get to this point at negative 2, 2. So our first interval begins at negative infinity, and it ends at negative 2. We know the negative infinities get a parenthesis, and for the increasing, decreasing, and constant parts, the intervals are always going to end with a parenthesis, regardless of what the number is. So you don't have to ask yourself any questions for increasing, decreasing, and constant. They all get parentheses on these kind of problems. So we're just going to do that. I would explain to you why we're doing that, but it would require a more specific definition of increasing, decreasing, and constant. And that has to do with slopes or whatnot. And basically that's because there's no point to the right to use to find a slope with, so you can't really determine what the slope is at a single point, at least until you take a calculus class, and in which case we will define how to do slope at a single point. But that's a couple of years away if we ever get there. Okay. The next section begins at 4, negative 3, and it ends at this arrow, which is going to the right. So that's positive infinity for the x's, and it points up, so positive infinity for the y's. So we're going to go from 4 to positive infinity. So far, so good. Very similar to positive negative 0, right? Usually the hardest part for students is kind of keeping those two straight. If they're able to write intervals, the hardest part becomes, okay, which one is the uphill and which one is the above and below, because the two words are kind of similar, at least English language meaning, right? Positive and increasing are both kind of similar. Okay, how many decreasing sections do we see? Let's do that part next. I see just one. It's this part right here. Everybody okay that? So that decreasing section begins at the point negative 2, 2, but all we care about is the x. And it ends at the point 1, negative 3, but again, all I care about is the x. And I know that for this increasing, decreasing, and constant, everything gets a parenthesis, so I don't have to think too hard about that part. And then for constant, well, I see one flat section here. That one flat section begins at the point 1, negative 3, but all I care about is the x. And it ends at 4, negative 3, but all I care about is the x. And everything gets a parenthesis when we're doing increasing, decreasing, and constant. Does that feel okay to you guys? So again, not much different than positive negative 0. It's just a different attribute that you're describing. Instead of above and below and on, you're talking about increasing, decreasing, and constant. Or uphill, downhill, and flat. Okay? So again, the definitions of these things are not hard to identify. Keeping them straight may be challenging. Using the notation properly, probably the biggest challenge. Getting comfortable writing these intervals, but we've been doing this for a couple of days, so hopefully that feels like it's getting easier. And you guys are asking good questions about the notation in terms of like, when does the order matter and that sort of thing, which makes me, makes me think that we're getting a handle on this, because you're thinking about, like the what if kind of questions, which is good. Okay. The third attribute that we'll talk about today is end behavior. Actually, hold on one second. I'm going to wait and do this in just a second. I want to do Extrema first. I'm sorry. So when we say Extrema, we're talking about the relative highest or lowest points on a graph. So when we talk about Extrema, we have two types. The first type is maxima. That's the plural for maximum, is maxima. And these are highest points, not shocking. And the other type is the minima. Oops. And then for either maxima or minima, we have local or global. So when we talk about a global maximum or minimum, that's the overall highest or lowest point. A local maximum or minimum just might be the highest or lowest in its relative neighborhood. So we'll do some example here to kind of get us familiar with this vocab a little bit, because it's not hard once you kind of see what we mean, and a picture usually helps more than the definitions do. But before we draw the picture, I'd like to kind of tell you about what it is that we're looking for. Let's use a different color here. And I'm not going to include any points on this because right now all I want us to worry about is just like, we're going to focus on where these points are. Okay. So when I look at this graph, how many maxima do we see? I see two. I see the one at the top of this hill, and I see the one at the top of this hill. Okay with that? So if I look at these two maxima, is either one a global? Is either one the highest overall point on the graph? Yes. The one on the right. Everybody agree with that? Now, the other one then is not the highest overall point, but it's the highest in its general area, right? The other one is a local. Is everybody good there? Okay. So now let's look for minima. How many minima do we see in this graph? I see just one. That point right there. Is this a global minima? No. Why not? The ends of our graph are pointing down, right? So there are definitely points that are lower than this minimum, which means that instead of it being global, it is only local. Is there a global minimum for this graph? No. Because the arrows are pointing down. Any point you find, we can find one lower than that because those arrows are going down forever. So the global max or min doesn't necessarily have to exist. Everybody's okay with that? Could you have more than one global maximum or minimum? Sure. What would it have to look like? Let's look at a little example. So I'm going to draw almost the exact same graph as before. I'm just going to draw those two humps at the same height. So in that case, both of these are global maximums because it's a tie for first. They're the tied for overall highest. So you can have two global maximums, or 3 or 4 or 5 or 100 or 10,000 or infinitely many. What does infinitely many look like? Where like all of those points are global maxima. And because it's a connected segment, there's infinitely many points on it. So there could be infinitely many of these extrema, either maxes or mins. Okay with that idea? So that's the whole idea. That's it with the extrema. What I would like for you guys to be able to do is to be able to find these with your calculator and find the exact x and y coordinates for these. Let me show you how your calculator can do that. If you have your graphing calculator with you, I'd invite you to take it out and follow along. If you don't have it with you or haven't got your graphing calculator yet, that's okay. Put it on your to-do list to get. And if you have it and it's at home, put it on your to-do list to bring to school. And we're going to show you guys how to use that graphing calculator right now. But if you're not able to follow along, we have the video. I'm recording this, so it'll be on PowerSchool. You can always go back and reference this video if you forget how to do things. And you can watch this again, and it's because the simulator I'm using is basically the exact same thing that you have. Should be relatively easy to follow along. In the case you're watching the video to follow along, might I suggest pausing is often helpful while you're looking on your calculator, so I'm not getting ahead of you or whatever. So taking advantage of pausing the video, I think, is often quite helpful. Okay, so first thing we need to do is turn on our calculator. The on button is located in the lower left-hand corner. I know that seems stupid that I'm asking you to do this, but some of us haven't used the graphing calculator yet before. We just bought it, and so I'm going to be kind of remedial with things because I know that some people, it's the first time they've touched this thing, which is fine. So what I'm going to do, let me explain what I'm going to do here first. What I'm going to do is I'm going to graph a function. I'm going to use its graph then to visually identify where the maxima or minimum are. And then I'm going to use a function in my calculator that when I give it a range of values, it finds the maximum or minimum in between that range. And I'm going to do that for each one that I see on the graph. Okay with that plan? Okay. So if I need to graph anything on my calculator, the button I'm going to press is the y equals button that's in the upper left-hand corner. Can you guys see the screen? If you need to turn the lights off to see better, I know the calculator is sometimes tough to see. Just stand up and turn off the lights if you think it's hard to see. You don't ever have to ask. If at any point we're doing something on a presentation, you can't see the screen good enough and turning the lights out will help. Just stand up and turn the lights out. You don't have to ask me. No permission is necessary. Chances are if you can't see, somebody else can't see. And I know early in the year like this, while the sun is still out, early in the morning, first hour is still sometimes too bright to really get a good view of this. So all I did was I pressed that y equals button in the upper left-hand corner. Now I have stuff here. Some of you may have stuff already in your y equals menu. Some of you may not. Whatever's there, we don't want it. So what we're going to do is we're going to clear it out by pressing the clear button, which is right below the down arrow. And it's worth doing, especially if you haven't used your calculator in a while and you have had it, is to just scroll through and make sure there's not a bunch of gobbledygook somewhere in it. So I'm going to scroll all the way down to all my different y equals slots and just make sure that they're all blank. If I do scroll down and find anything in there, I want to clear it out. So the first time you're taking your calculator out for the year, it's often a good idea to do that just to make sure that there's nothing else in there that'll cause a problem. Okay, so what I'm going to graph is this function here. So I'm going to do x plus 2 in parentheses, and x in parentheses, and x minus 3 in parentheses. The x button is right next to that green alpha button. And then I'm just using the numbers and the plus and minus signs. And the parentheses are above the 8 and the 9 on the keyboard. Let's do this real quick. Oops. The X is right next to the alpha key. So the green alpha button there on the kind of upper left-hand part of your calculator, right next to that is a button that says X, T, theta, or N. So depending on the mode of your calculator, when you press that, it'll display as one of those variables. The mode our calculator is going to be in for the entirety of the year, you're always going to get an X. But this is what I've typed into that first y equals spot. Okay. Yes, Andrew. So I've written down here exactly what I've typed into my calculator. So it's minus 3. That's what's going on there is that's like a little arrow showing you that there's more stuff off the screen that you can't see. So that's all that symbol is going on. There's not actually anything there. It's just the 3 in the parentheses is all you can't see. Everybody got this typed in? Okay. So the next thing I'm going to do is I'm going to then ask my calculator to graph this. So there's a couple of ways that you can do this. What I think is often the best starting one is to pick a standard window to graph over. So the calculator's built-in standard window, it builds its x-axis going from -10 to +10, and its y-axis going from -10 to +10. So it just gives you like a little square picture. So to get it to do that, we're going to press the zoom button, which is up here at the top row in the middle. And we're going to pick Z standard. So just scroll down to Z standard and press enter. Or if you press the number 6, because it was option 6, it'll pick that automatically. And you should get a graph that looks something like this. Yes. So you picked the zoom button that's in the middle on the top row. The gray zoom button, the very top row in the middle. And then you picked option 6, which is Z standard, and pressed enter. So you should get something that looks kind of like this. If you didn't get something that looks like this, the odds are that what you typed into the y equals menu wasn't quite right. So you probably had an error. Maybe you forgot a parenthesis in there, or you typed the wrong number, or you did a minus instead of a plus. All of those are possibilities, but if you typed it in correctly, you should get a graph that looked like this. So the calculator doesn't make mistakes. You make mistakes when you type things in and try to get the calculator to do something it doesn't know how to do, or isn't what you mean, even though it's what you told it to do. Okay? The calculator's really dumb. You have to be really specific in terms of what you want it to do. It does what you tell it to do really, really well, but your directions have to be really clear for it. Okay? All right, so if I look at this, I see one local maxima that is right about here. Everybody agree with that? And I see one local minima that is right about there. Everybody okay there? Okay. What I want the calculator to do now is to tell me exactly what the x and y coordinate is for those points. I'm going to have to do it one at a time. I'm going to have to do it once for each extrema that I see, but that's okay. So to get it to tell me what the maxima are, I'm going to press the second button, which is that blue button in the left-hand corner, upper left-hand corner. And then I'm going to pick the trace button, which was right next to the zoom. And it's going to open up this calculate menu. So this calculate menu has tools that you can use on a graph. So if you're looking to do something to a graph, this is the menu that houses all the commands that do things to the graph of a function. Now, if we're looking for a maximum, which one of these commands sounds like the one that we're looking to use? Probably command 4 that literally says maximum, right? So let's go down and select that. Now, if you look at your calculator screen in the lower left-hand corner, you notice it's asking you a question. It says left bound with a question mark. You might also notice that on your calculator screen, there's a flashing cursor. Mine is located right here at the origin. Yours may be somewhere else. What I need to do is I need to move that cursor so it's on the left side of where I think that maximum is. So I'm going to do that just by using the left or right arrows. So notice that my cursor is moving. And as long as I get past that maximum, it doesn't really matter where I pick. So right now, if you look, my cursor is past the maximum. It's on the left side of the maximum. So I'm going to go ahead and press enter there. It doesn't matter where left of the maximum you pick. It just has to get somewhere left of the maximum. When you press enter, you'll notice that the question changes now. In the lower left-hand corner, it now says right bound with a question mark. So we're going to repeat that process. We're going to move our cursor now so it's on the right side of the maximum. So I'm just going to use the right arrows to move my cursor over. And now that's somewhere definitely right of the maximum. So I'll press enter again. And you notice it's going to ask me a third question. Down in the lower left-hand corner of the screen, it says guess, question mark. Here's a little hint. You could move your cursor so it looks like it's really close to that maximum. It doesn't matter though. Like if you press enter right where it is, the calculator is still going to find that maximum and it's not going to really find it noticeably faster than if you moved your cursor there. It's going to be like microseconds faster. So I don't even bother ever moving my cursor a second or a third time. So I just pressed enter again. And now on the bottom of my screen, you notice it says maximum. And it gives me specifically the x and y coordinates. So if I was on my homework and I asked you to round this to 3 decimal places, max at, say, negative 1.12, well, if I want to round 1.1196, that rounds to 1.20. Everybody's okay with that? I included the 0 at the end because if we're doing 3 decimal places. And then my y coordinate would be 4.06, and then I have 0.6, so that rounds to 1. So 4.061. Is everybody okay with that? Did we get the same max or min when you guys tried it yourselves? Everybody should get the same answer because we typed in the same function. Okay? Let's do it now for the minimum. So I'm going to go back to that menu, the calculate menu. So I'm going to press second and then the trace button again. But this time I'm going to pick the minimum command because I'm looking for a minimum. And I'm going to repeat the same left bound, right bound guess. So I'm going to move my cursor somewhere so it's left of that minimum. That looks good. I'll press enter. And then I'll move it somewhere to the right of that minimum. That looks good. I'll press enter. And then for a guess, I don't need to move it at all. Where it's at is going to be fine. So I'll press enter one more time. And it spits out the value for my minimum. So I have my local minimum at, again, I'm going to round to 3 decimal places, 1.786, comma, negative 8.21. Do you guys feel okay using the graphing calculator to do this? I'll have a couple of problems in the homework where I ask you to use your calculator to find the max or mins and round your answer to 3 decimal places, just kind of like we've done here. But you notice that there's nothing, once you know how to use the calculator, there's nothing complicated that you need to do, right? All the inputs that you're giving the calculator are visual things where you just need to find points on either side of the max or min is really all you need to give the calculator. It's remembering the button sequences to get to all the menus that you need that'll be a challenge. Yes?
On the homework, is there going to be like where you have to find the global and the local?
Sure, there could be multiple minima in the picture. You do the same thing. It doesn't matter whether it's a global or a local that you're looking for. The minimum or maximum command is going to work the same way. Now, you'll have to identify visually which one is which, but you don't have to do anything different for a global versus a local. This is a good question. Do you guys feel okay with the calculator thing here? Again, if you get stuck, we can review it, or you can go back and look at the video and look at this section. If I can figure out how to do it, maybe I'll even snip out this section where I use the calculator and post it in as a separate video also, so you don't have to weed through the whole 80 minutes of recording to find the spot you're looking for. Or if I can't, I can probably at least give you a time window-ish, like the calculator happens between 45 and 55 or something. So it makes it a little bit easier to find if you need to. Okay, so that's Extrema. The last thing that we're going to talk about today then, where are we at 4, I think, is this idea of end behavior. And again, in keeping with our theme of the day, I'm not going to give like a really specific definition for what we mean by end behavior. I'm just going to kind of give you a you know it when you see it kind of definition, which is what we're really doing is we're just using our eyes to identify things from a graph. So our end behavior is just a description of what the arrows on the graph, maybe I should say how the arrows on the graph are pointing. And we'll have a special notation that we use to kind of indicate that, but that's all the end behavior is describing, is how those arrows are pointing. So let's do a little example, and we'll write down the end behavior for this graph. So we'll start first by just making a description in English, and I'll show you how to translate that English into symbols. because I think that's usually the easier place to start, because intuitively, this is an easy question, right? So if I look at this arrow on the graph, I need to identify two things, right? I need to identify whether the arrow is at the left end or the right end, its location, and then what direction it's pointing, up or down. Everybody agree with that? So I would describe this one as the left arrow, and then I would say it points up. That seems pretty obvious, right? That's easy to see just by looking at the picture. I'm going to leave a little space underneath that sentence because I'm going to write some symbols under there in a second. But I want to write the verbal or the English description for our other arrow before I go and start doing the symbol. So I'm going to leave a little space. This other arrow, we would call this the right arrow. And we would say this one points down. Everybody agree with that? Okay, so now let's translate these two phrases into symbols. So for left arrow, so the left and right is talking about the x coordinate, right? The x coordinate moves a point left and right, or describes its left and right location. Everybody agree with that? So my x arrow, or my x coordinate, is going to positive infinity because that end of the graph is pointing to the left. Everybody okay with that idea? So when we say left arrow, we're just talking about x going to positive infinity. That's how we write that. Now, pointing up or down is talking about which coordinate, x or y. Y describes the up and down location of something on the xy axis, right? So since y is talking about up and down, we'll have y. And if we're going up, y is going towards positive infinity. Very similar to the idea like when we wrote down and thought about the arrow as a point when we did the intervals. Everybody's okay with that? Okay. So for the other end of our graph, oh my God, everybody, how come nobody's yelling at me? That should definitely be negative infinity, right? Ah! The left end of the x-axis is where the negative things live. Come on now. You guys know better than that. Somebody should have been yelling at me like, whoa, that doesn't make any sense. If you see me make mistakes, please stop me. I will never object if you're like, hey, oh, hold on. Are we sure on this? And even if you're wrong, which it's fine, like, you're not going to be the only person thinking, wait a minute, maybe this doesn't make sense and maybe it deserves a little bit more explanation, which is good. Like, interrupt me if things don't make sense. That's okay to do. Sometimes it'll be because I did something stupid, like wrote down the wrong thing. Sometimes it'll be because I did a bad job of explaining and you don't understand. Either is okay. Nobody's going to be mad about it. Okay? All right. So continuing on, let's finish out this example. So the right arrow, again, if we thought about this as an ordered pair, we would have written this arrow as positive infinity comma negative infinity. So our x is going towards positive infinity, and our y is going towards negative infinity. So when we talk about writing the end behavior, this is what we're looking for. But I wanted to start with like an English language description because these symbols don't make a lot of sense until you kind of phrase it as just a shorthand for words, right? And we do it this way, it's like, oh, okay, so that's easy to do. Because at least you know how to do the description, and then you just have to worry about the notation. Because the description is very common sense. The natural question here is, could this ever be something other than infinities here? It could. So I wouldn't expect to deal with this right now, but later on this year, we're going to talk about a feature called an asymptote. Let's say this is y equals 1. So an asymptote is a line the graph approaches but can't touch or cross. It's like a force field, like an invisible boundary, where you get right up next to it, but you can't actually get there. So on this situation, let's use a highlighter, I think. Notice that our left and right arrows aren't pointing up or down, but they're pointing kind of in a flat, right? So we'll still start this the same way. Well, x approaches positive infinity. That's our right arrow, or our left arrow. Oh my goodness. Okay, left arrow is towards negative infinity. Jeepers creepers, Kulik, just slow down. And what y value are we approaching? Because we're flat, it could be any y value, but in this case, it's specifically going to be the y value for our asymptote. So y1, well, it's because the asymptote is the line y equals 1. And then the other end is going to be basically the same thing, except the x is going towards positive infinity. Everybody's okay there? So that's a natural second question after we do this, is like, won't it always, the x's and y's just have positive or negative infinity? And it's like, well, no, but this is a situation that you're probably not familiar with, right? Because I'm guessing that probably none of us in our Algebra 1 class talked about an asymptote, which we will this year, but not right now. So I think that's good for today. You guys we did a lot of good stuff. I'll post the new homework assignment here for this section on both PowerSchool and in the content library. I'll also, for Thursday, you guys know you have a work from home day. I just have a cumulative review assignment for that day scheduled, and I'll post that already to both PowerSchool and into the content library. Basically, it's just going to ask you to do some problems involving all these ideas we've talked about so far. So it's just like a mid-chapter review kind of assignment. So there's no lecture to watch. There's no new content to be done. It's just going to be practice on things that we already kind of know how to do. So that's all I have scheduled for the Thursday. Everybody happy there? Okay. Well, I'm done, so you guys can relax. And I'll get that stuff